In this video, we are going to be looking at a challenging example of a percentage yield question. Now, this question is quite a bit different from the other ones you would have seen because it's based more on application, thinking, and problem-solving strategies, and less about applying a set of steps that you would have previously just practiced. So this kind of a question requires a very, very thorough understanding of what percent yield actually is. So let's read the question. In the synthesis of sulfanilamide, 1 mole of benzene produces 1 mole of sulfanilamide. If the percentage yield is 80%, how many grams of benzene do you need to start with in order to obtain 463 grams of sulfanilamide? So when you read a question like this, a really good first step is to start to extract some relevant information from the question. So when we read this, the first thing that I notice is 1 mole of benzene produces 1 mole of sulfanilamide. That tells you the mole ratio of sulfanilamide to benzene is 1:1. And then if I were to see information like that in a question, I would think, okay, I'm given a ratio of moles. Where is a concept where we have seen that before? Oh, right, quantitative relationships in stoichiometry. So this is probably a hint for me that I'm going to need to apply some kind of stoichiometry concept to this question. So that's the first piece of information. The second thing that we're told is that the percentage yield is 80%. So I'm just making this into a data list off to the side in the blue ink here. A really good strategy for every single time you ever solve a problem in chemistry or even physics or senior math classes, always make a data list. So we see that the percent yield is 80%. And then what else are we told? In order to obtain 463 grams of sulfanilamide. Okay, so the question says to obtain 463 grams of sulfanilamide. Now we know that if we're dealing with percent yield, that tells us a ratio of actual yield to theoretical yield, and the question says to obtain. So that is a really big hint to me that we are dealing with the actual yield there. So the actual yield is 463 grams. And then the question asks, how many grams of benzene do you need to start with in order to obtain 463 grams of sulfanilamide? So what we do need to know, we're going to need to know the theoretical yield. So that's an unknown. And in case it wasn't clear so far, all of these things relate to sulfanilamide. All right, so we're dealing with percent yield and actual yield and theoretical yield. And the question is asking us for the theoretical yield of sulfanilamide. The reason why we know it's theoretical yield is because it says how many grams of benzene. So if we want the mass of benzene, that's kind of our final unknown. We know that we're going to need the theoretical yield of sulfanilamide. And also, in our mind, we are connecting lots of different concepts in chemistry. We know that if we want the mass of benzene, we're going to need to know the theoretical yield of sulfanilamide because we're only given information in terms of sulfanilamide. And we know up here that there's a 1-to-1 mole ratio. So this question is very challenging because it requires you to pull in all the knowledge from the unit and just really, really integrate everything together. Now in terms of steps, this is also a challenging question because we have to manipulate and perform algebra on a formula that we haven't had to before. So we know that the formula, and again, if you don't have this written down in your notes, you should have this written down. We know that percent yield equals actual yield divided by theoretical yield times 100%. All right, so that is a formula which is really, really good to write down. Now, see here, if we go back here, we want the theoretical yield. We know every other piece of information in this formula except the theoretical yield. So that would be a good hint for me when I'm reasoning my way through this problem to think, okay, my next step is probably that I need to perform algebra. So a good way to do that is first what I'm doing, we'll see percent yield equals actual yield over theoretical yield times 100%. And then I'm just going to divide both sides by the 100% because that'll allow us to cancel it out on that side. Then we have percent yield divided by 100% equals actual yield divided by theoretical yield. But we still want to get theoretical yield on its own. So now I'm going to multiply both sides by theoretical yield. And then we're left with the theoretical yield. And again, I realize that this could have been done in less steps. I just want to make it really clear where all the numbers are coming from. So theoretical yield times percent yield over 100% equals the actual yield. Once again, multiplying both sides by 100%. Then we're left with theoretical yield times percent yield equals actual yield times 100%. Then we're going to divide both sides by the percent yield. And that's going to allow us to isolate theoretical yield on its own. So the theoretical yield equals the actual yield divided by the percent yield times 100%. So we know from our data list, actual yield, 463 grams, percent yields 80. So then we just sub in those numbers. So 463 grams divided by 80% times 100%. Now when you type this all into your calculator, you know that you're going to get a final unit in terms of grams because the percentages are going to cancel out. So this tells you that 478.75 grams is the theoretical yield of sulfanilamide. All right, so that's the theoretical yield of sulfanilamide. So we've now found that piece of information, and we just want a mass of benzene. So now at this point, you see how we have a mass of sulfanilamide, and we want a mass of benzene. So now this just becomes mass-to-mass stoichiometry, which you've seen explicit examples of earlier on in the course. So at this point, it's just about mass-to-mass stoichiometry, and even better, we get to save ourselves a step because we don't have to deal with a balanced equation because we've already been told the mole ratio of sulfanilamide to benzene, which is great and can save us a lot of time. So since there's a 1-to-1 mole ratio of sulfanilamide to benzene, all we have to do is find the moles of this, perform stoichiometry, and then find the mass of the benzene. So for sulfanilamide, again, we want moles. So we know that moles is equal to mass over molar mass. And we have 578.75 grams divided by the molar mass of sulfanilamide would be 173.2143 grams per mole. And you type that in your calculator. I'm just showing this here to I'm just canceling out the units to make sure it's clear why you get final units in moles. And then you should get 3.3412 moles of sulfanilamide. All right, so now we have the moles of sulfanilamide, and then we remember we don't need to do like the recipe way. We don't need to set up a conversion factor or an equivalent multiplier to do the stoichiometry because we were told there's a 1-to-1 ratio. We already know that. So since there's a 1-to-1 ratio, that means that in this reaction we would get an equivalent number of moles of benzene being made. And then our next step is just that we want to find a mass, because that was in our data list, right? Mass of benzene. So I'll use my same formula I used earlier, where moles equals mass over molar mass. And then to isolate mass on its own, I'm going to multiply both sides of the equation by molar mass. That will allow me to cancel out the molar mass on the right side of the equation, and it leaves us with mass equals moles times molar mass. So we know we're having 3.3412 moles of benzene, and then the molar mass of benzene, which is C6H6. Now that's something, this here is something that on a quiz or test you would just be given the information, but in homework you can just look it up on Google. The molar mass of benzene is 78.1134 grams per mole. And then you type that into your calculator, and right here I'm just canceling out the units of moles to make it clear that we're going to end up with final units in grams, because grams is a unit of mass. So then our final answer is going to be about 260 grams. So therefore, 260 grams of benzene are needed in the reaction to get 463 grams of sulfanilamide. So this was a pretty challenging question because it was a thinking question. It's not something that you had seen before. So these things, the way that you practice them is more about practicing the strategies. So see some of the things that I did here. I made a data list up at the top. Now that's a really good strategy for all of you to try. I wrote down any formula that I thought was relevant. That's also a really good formula, a really good strategy for you to try. And I kind of reasoned my way through it, and I thought, what other similar concepts have I seen before? And that allowed me to remember, oh right, mole ratios, stoichiometry, all of that. And then the algebra. Now algebra is just an important skill in senior math and science that will require some practice. If anyone's looking for resources on algebra, then please ask. We performed algebra to isolate theoretical yield on its own. Then we got the theoretical yield of sulfanilamide. Then once we had a mass of sulfanilamide, we knew because we made a data list that we wanted a mass of benzene. And then because we had a mass and we wanted a mass and we remembered that a mole ratio was given, then that allowed us to think, oh right, stoichiometry. And if I have a mass and I want a mass, what have I seen before that's similar to that? And then we would think, right, mass to mass stoichiometry. So then it was just a matter of using the skills from earlier in the unit to find the moles and then converting between moles of sulfanilamide to moles of benzene, which was pretty quick work because it was a 1-to-1 ratio. And then we just did a little bit more algebra at the end to get a final answer, which was 260 grams. So that's the complete worked solution of this thinking question. If there's any particular concepts in there you'd like to review, then please let me know.